Hi, in this video, I'm going to show you how to solve a radical equation, more specifically a square root equation. So if you're looking at the equation on the left, what we want to do is when we're solving, we want to perform opposite operations. So on the right, I am showing you the PEMDAS pyramid, which is basically simplifying. You go from the top of the pyramid down, and when you're solving, you're going to go from the bottom of the pyramid up. So let's look at the equation. The square root of 2x plus 9 equals 5. And then what we're asked to do is you always want to check for extraneous solutions. I'll talk about that in a moment. Looking at our equation, we have the square root of 2x plus 9 equals 5. So looking at the pyramid, that would put us right here under exponent. We are using opposite operations. So the opposite of square rooting is squaring. So what we want to do is square both sides. If I square the left side to get rid of the square root, I'm also going to square the 5. The radical and the square cancel, and we are left with 2x plus 9 equals to 25. From here, we basically have a two-step equation. Subtract 9 from both sides. That brings us to 2x is equal to 16. And then you could see that our next operation would be division, because the opposite of multiplying by 2 would be dividing by 2. So we end up with x equals 8. All right, but now that we have our solution, we always want to make sure to check it to see if we have any extraneous solutions. So what does an extraneous solution mean? An extraneous solution means if we end up with a negative after we simplify, then that is not a real solution, and we are looking for real solutions. So that will not be counted. Another situation is if you simplify and your radical ends up equaling a negative number. That is also something we cannot use. So we're going to check if we get any one of these happening. So looking at our original equation, we have 2, and I'm going to plug in 8. I could already see, I don't know if you can see it, that if we simplify this mentally, this works out just fine. So this is our original equation where I plugged in the 8. 2 times 8 is 16, and 16 plus 9 is 25. And so we end up with the square root of 25 equals to 5. So this is true. So that means our solution is x equals 8. Now, anytime I'm solving an equation, another way I like to show it is using a graphing calculator. If you look at the equation, the solution occurs where the left side, square root of 2x plus 9, is equal to the right side, which in this case is 5. So if we graph that on a graphing calculator, that means they're going to intersect at x equals 8. So let me show you what that means. All right, so the square root of 2x plus 9, I'm going to write that on the graph. So we could see that the equation of the square root of 2x plus 9 is this following graph. So if I graph the right side, which is y equals to 5, we could see that the intersection occurs at this point at 8, 5. So the solution is where the left side intersects the right side. I can write y equals 2 here. So our left side was square root of 2x plus 9, which is this red curve. That's a square root function. And then y equals 5 is just a horizontal line. The intersection occurs at 8, 5. That means when x is 8, y is 5. Now, if we looked at when we solved this equation, if I went ahead and I plugged in 8 to this equation, in other words, for x right here, when x is 8, we could see that y is 5. And that is an example with a non-extraneous solution.